Okay, for the woman electrochemical cell fire lab, I could not get the fire to start. Um, and I tried and tried and tried, and I don't know what happened. I just couldn't get it to start. So the procedure, those are the pictures, of what I did. I tried to use some more toilet paper too a couple times to see if the heat would help the fire to start, and I had no luck. So yeah. I used the lemon, 6 copper clips, wire, steel wool, and 6 zinc nails. I pushed the copper clips into the lemon on the same side and about 1 centimeter apart, and I did the same thing with the zinc nails but on the opposite side of the copper clips. And then I connected the first copper clip to the second zinc nail, and so on. I just continued that down the lemon. And then there was a nail on each side that was open still, and so I connected a wire to each side. The copper clips were considered positive, and the zinc nails are considered negative. The lemon should have produced 5 volts electricity, which I don't think mine did, and I think that's the reason why the fire did not start. And then I made a little pile of steel wool and put some toilet paper on it. So why does this work? Batteries are containers for chemical energy. When 2 electrodes, each of different kind of metal, are placed in a liquid electrolyte, which was the lemon, and connected by a conductive material, they generate electricity. Lemon juice is a good electrolyte, and this makes a tangy fruit a perfect fire starter. In this case, the electrodes, were the zinc nails and copper clips. And so you stick that into a lemon and it connects them in a series, positive to negative, to one another, and leaves the ends free for the wires to connect to. Touching the exposed wires leads together, and the steel wool completes the circuit and causes the spark to start. The video uses this to ignite the toilet paper into a small fire. So a little background. Batteries are containers that store chemical energy. They can be converted to electrical energy, also known as electricity. This depends on the electrochemical reaction to do this. The reaction typically occurs between 2 pieces of metals called electrodes and a liquid or paste called an electrolyte. For a battery to work well, the electrodes must be made up of 2 different types of material, which were the copper and zinc. This ensures that one will react differently than the other with the electrolyte. This difference is what generates electricity. When you connect the 2 electrodes with a material that can transport electricity well, which is called the conductor, and the chemical reaction should fire up. The battery is generating electricity. As you make connections, the electricity likes to take the path of the least resistance. If there are multiple ways to go from one electrode to the other, the electricity will take the path that lets it flow the most easily. Aluminum foil is a good conductor. Electricity flows easily through it. The electrodes are as common as copper pennies. So in this experiment, instead of using the copper clips, we could have used copper pennies, and it has the same concept. It should have done the same exact thing that, well, not in my case, but it should have done the same exact thing as the copper clips. It should have helped start the spark and then made the fire happen. And then as for electrolytes, they're found all over the place. I kind of did some reading online on Google, and it like kind of took me by surprise. I guess I don't think of it on an everyday basis, but they said like the most common place to find electrolytes are all over the kitchen. There's like multiple places in the kitchen, which now that I've read that, I mean it makes a lot of sense because just like Gatorade has good electrolytes, and just a bunch of stuff of like food wise. And so, I mean, before this, I didn't even think about like having all these electrolytes in my kitchen, but it's true. Um, so yeah, the observations and results. The battery that was just made has copper and aluminum electrode separated by the electrolyte lemon juice. And then this generates electricity as soon as the electricity has a path to flow from one electrode to the other.